So some implicit differentiation. This is 3.7 in the Stewart 5 textbook, page 188. 1 plus x equals sine of xy squared. And I want you to find dy dx. Derivative of 1 is 0. Derivative of x is 1 dx, but we divide. And now we have a big old chain rule and product rule mix. Okay? We know the derivative of sine is cosine. So derivative of sine is cosine. Boom. Times the derivative of the inside. Derivative of the inside, now this will be a product rule. So I always do x first. So derivative of x is simply 1 dx, but we divide by dx as we go. So it's 1y squared plus x, and the derivative of y squared is 2y dy divided is y prime. So immediately we're sitting here at this, all right? Now it's a little ugly, so to make it a little easier for the algebra, because again, this is an algebra exercise, I will distribute the cosine to both terms. All right, and by doing that, that just keeps everything a little cleaner. All right, so I get y squared times cosine of the argument. And remember, when you're taking derivatives, the argument never changes. And I can't stress that enough to new students as they do this work. You knew that sine would have, that all trig would stay with that argument. All right, now, and then I distribute it again, and I get 2xy cos xy squared, and then I'll put the y prime at the end. So there's only one y prime in this three-term thing after you distribute the cosine. So move over the one without y prime. A little smaller, let's give us room. So I get 1 minus y squared cosine xy squared equals this. But I tell you what, this is a problem so simple by the solving problems that I'll just divide by the coefficient of y prime, which was that, and that equals y prime. It's moving this over and then dividing by this quantity. And everyone, that's the derivative. And it takes some practice. It takes some practice. The next one has a lot of the same in it. If we erase this, and you can try it. It has an argument going on, and it has product rules on both sides. So 14 is y times sine of x squared equals x sine of y squared. And obviously it's a product rule on the right, it's a product rule on the left, and each of the trigs has a chain rule inside. All right, so let's start with the right side. And again, it's a chain rule. Because of the x squared having the sign, I'll probably do the derivative of y first, just work left to right. Derivative of y is 1y prime, because again, dy divided by dx. So y prime sine of x squared plus y times derivative of sine is cosine. Do not change the argument. The argument stays x squared. Now times, you do the derivative of the argument. It's 2x dx, divide by dx already. So this is this side equals, other side, derivative of x is 1 dx, divide by dx, so it's just 1. So it's just sine of y squared plus x. Now the derivative of sine is cosine. Argument doesn't change. And derivative on the inside, and the derivative of the inside of y squared is 2y dy divided by dx is y prime. So again, when you take a derivative with respect to y, you get y prime. When you take a derivative with respect to x, just is the, you don't put dx. And now it's algebra. It is algebra. Here's a y prime term. Here's a y prime term. It doesn't matter. It'll just be a sign difference. There's two ways to do it. I will send this here and this here and rewrite it. All right. So if I go a little smaller, so we have some room, I'm going to get y 2xy cos x squared. I just rewrote this term minus sine y squared, and it's going to equal. I'm going to factor out the y prime at the same time, guys. I'm going to factor out the y prime at the same time. So I'm going to write y prime times this term right here would be 2xy cosine y squared. Then over here, minus sine x squared. All right, so now we can write the answer: 2xy cosine x squared minus sine y squared all over 2xy cosine y squared minus sine x squared. And that's the answer to number 14. And again, they get big, and you have to keep track. The calculus literally ends here. And this is just algebra solving for a variable. All right, let's try the next one, number 16. I'm going to erase this. Last one on of the evens in this little section of practice problems. If I go back up to the top, maybe we can just get 16 in the window. There we go. Again, now we can see it's going to be a chain rule because it's the square root of x plus y equals 1's easy, x squared, y squared. So you got a chain rule and a product rule. All right? Everybody, if you're not seeing that this is x plus y to the half, you are going to be stuck. All right? So you got to start with that step to make this problem really possible. All right? So, sorry about that. I'll take the derivative of this. Power comes down, so it's half. X plus y half minus 1 is negative half. Times derivative of the inside. Derivative of x is 1 dx. Divide by dx. Plus derivative of y is 1 y prime, so just y prime. We have to do some distributing again. Equals, on the other side, 0. And then we get, so I could write this as 0, but I'm not going to. It's 0. We know it. Equals, so derivative of x squared is 2x dx, but we divide by dx. And again, this is simply solving for y primes. It is a pain. It is a pain. It is a pain. I don't know. There's no good answer here for how to handle this. I hate the half. I hate it, hate it, hate it. So I'm going to multiply everything by 2 first. Do that. 3 terms. There were only 3 terms in this thing before you, so I'll do that. So I get x plus y to the negative half when I distribute, plus y prime x plus y to the negative half equals 4xy squared plus 4x squared y prime. So I got 2 terms with y prime, 2 terms without. This is so I'm going to move this one this way, this one this way. There's no right answer to which ones to move. It's just I pick. So I have 1 over the square root of x plus y, that first term. I don't know if dead space my board here going on right there. And if I brought this one over, it'd be minus 4xy squared equals 4x squared y prime minus y prime over the square root of x plus y. And there we are. And now the problem here is that when you divide, right, you're going to have fraction over fraction. So this is kind of ugly. Because we factor out the y prime. Yeah, it does this. All right? But you can't write this stuff divided by this stuff and expect credit. All right, so before I start, well, now let's start there and then we'll fix it. So it's 1 over the square root of x plus y minus 4xy squared over 1 divided by the other side, which is 4x squared y over 1, not the same, minus 1 over Now, students get desperate. Don't get desperate. Don't start doing stupid stuff like this, right? They're not the same. They're sums you can't cancel. You just got to drag your feet and live with it. So I see that I'm going to have to get a common denominator in the top of x plus y, and the same in the bottom. So you're seeing how this can really work out. All right, because once you make that step, the denominators will be the same. They'll just cancel here. So this, again, is a lot of algebra, and it's going to be a big problem before we're done. So the top becomes 1 minus 4xy squared, square root of x plus y, all over square root of x plus y, all over 4x squared y, square root of x plus y minus 1, all over the square root of x plus y. And this is all equal to y prime still. And now I can see these cancel. So my answer, and it's a big problem, so I'd maybe move the y prime over. 4 minus 4xy squared, square root of x plus y, over 4x squared y, square root of x plus y, minus 1. And everyone, this would be a very complicated problem. All right, takes practice. All right, if I go entire page, it's obviously a long problem. All right, so practice those odds, use your answer books, use the internet, keep practicing. That's how we get better at calculus.